Hi everyone, my name is Marilena Pagano and I am the Application Specialist at Hellma. Today I would like to welcome you to our second webinar for this year with Dr. Martin Hajduk on the topic PAT in the process industry, nice to have or efficient cash cow. Today's expert, Dr. Martin Hajduk, is the Managing Director of MHj-PAT Consulting. In his role, he advises developers, distributors, and users on the use of process analytical technology systems in chemical and physical processes. I'm glad he found the time to share his experience with us today. Welcome, Dr. Martin Hajduk.
Good morning, ladies and gentlemen. Marilena, thanks for the introduction. Today, I will speak about the successful process analytics. Today, I want to speak about most important points by installation of the process analytic technology measuring point. But last, not least, also about the cost. But at first, let me introduce myself. I study in Hanover physics, and my master thesis I'm writing about the developing of lasers for high resolution spectroscopy. It was my first contact with spectroscopy. Then I switched to the process engineering department and was a leader of the laser measurement technology at this institute. And after I finished my doctor thesis about small displacements measuring by holographic interferometry, I switched to the DEGUSA, nowadays Evonik Incorporation. I was the head of the process analytics technology. I make a lot of things about the process analytics. I have seen that most people have only 0 to 4 years about process analytic technology. I'm working my whole life in this area. So main focus by my projects was the liquid analysis, gas analysis, particle measurement, using difference of spectroscopy, also GC, particle measurement, sound emission spectroscopy. I make data analysis. I have a big project about prediction maintenance of chemical plants. And in my last years, I prefabricated containers with complete PAT installation for plant sites worldwide. So we planned the installation in Germany, makes installation here, but transfer the containers around the world. But we have also to look about the region laws, what we can, how we can install, how we can later on use these containers. Since 2017, I have my own firm, was managing director of the MHj-PAT-Beratung. So, but this was a lot about pronunciation. Let's have a look to the real topic. At first, I want to give you some examples about the process analytic technology, what is important for successful analytics. But I have another part. We have to look what's about the project costs. And at least we have to look about the economical benefit of the PAT measurement points. Normally, this is the most important point. If we have no good analytic methods and we have too high project costs, too long, we need too long time for the realization, the economical benefit will be not so good. But I can show you, and I'm sure that the most points you are working for will be a success. But what's important to have a good success? At first, we should make a big planning, and one of the most important questions is the question how we should install PAT measurement points. Did we need relevant information? The information should be not only relevant, it should be also reliable. That's very important later on if you make a control of the system. The results are stable, fast, and sufficient accurate to control the chemical plant. And possible, we make a quality control for the incoming and outcoming products. And it's very important that we are very reliably and accurate. We have to discuss with the customer what happens with the analytic result. We have a laboratory analysis at this point on why we have this and for what we are needing the results. It's only a documentation of stable process condition, or we want to use a control loop, then we need extremely reliably results, or we want to make quality assurance, then we need reliably and extremely accurate results. Here's an example. This is a powder, and we are measuring the pH value of the powder surface during the drying process. It's not so easy, but we find a possibility how to make it, and then we can control it, about the difference of the pH value, the adding of the acid. And you see here the real stable pH value. Sorry, this is a result from the 19th. You see, during this time, we don't have computers. We make really the results on a printer. One of the most points I have talked about in the last minute was reliable analytics. How we can come to such a reliable process. That's very important that we check all available process experience during planning. Very important is not only the normal operation, we have to check unexpected situations using startup or using cleaning process. Then very important, normally we use physical interaction between the molecules. So it's very important that we have enough numbers of molecules. So in my opinion, it's a better success if we are measuring in the volume, not on the surface. What means this? Volume effect, it's a typical density measurement or also absorption of radiation. Surface effects is a pH measurement or also using Raman probes. You see pH measurement, normally we have to calibrate 1 time a week. A density measurement or optical absorption, measurement using optical absorption. Normally we never calibrating again, or we have to look maximum 1 time a year to this analytic methods. And also very important, later on for better maintenance, it's very good to have a simple analytic system. I named it Keep It Simple and Stupid, a KISS analyzer. All people are knowing one of the most important things are the sampling and the sample preparation. The best practice, we know, around about 50% of the problems and faults depending from the sampling. So if it's possible, no sampling, we can make inline. This is more successful than sampling and sample preparation. What we have to do quite often, it's a gas analytic. Okay, I have here an example, quite easy. It's a distillation column, we have a feed, we have the button, the sample with a button product, but we want to have the distillation. We have here the gaseous phase condensated, then we have the liquid phase here. Normally, if all is correct, without gas bubbles and without any other liquids by using cleaning process, and then we can analyze at this point what's the quality and can go to the to our product tank, and but it's also possible to measure here. But what kind of problems we can have here? Possible we have a 2 or 3 phase flow. We have organic liquid. Sometimes we have still before starting water inside. Then we have also water bubbles, possible water bubbles inside. And if the temperature is not low enough, we have problems with gas bubbles. So we can use here, or normally we should use a sample cell in the vertical tubing, and we have also a look what we can do here before the sample cells, that water drops and particles and gas bubbles don't disturb our process. I have to reduce to the liquid phase. As the next examples, the analytic of liquid phase. And in this area, because we have multi-component analysis, normally a combination of physical measurements like refraction index, sound velocity, density, electrical conductivity is often not so successfully because it's not specific enough. So in the most cases in the past, I have used spectroscopy because spectroscopy is more selective. Now we have different possibilities to use spectroscopy. We can use visible, NIR, and also ER analytics. I reduce my examples to the NIR analytics. So we reduce to liquid phase NIR analysis. I want to have an absorption sample, so I can get a volume effect. And if possible, inline analysis. So in our most applications, we can use 2 different spectrometers. That can be the FT-NIR spectrometer. We have a further spectrum from 1,000 to 2,500 nanometers. That means 10,000 to 4,000 wave numbers. And we have one high sensitive detector with low noise, also a high resolution of the spectrum. But the measurement is slowly and sensitive to vibration. So normally we have to install the NIR spectrometer not inside the plant or outside the plant, and then we have a long glass fiber connection to our sample point. Other possibility is a diode arrow NIR spectrometer. We have a smaller spectrum, 1,000 to 700 nanometers, sometimes also to 2,000 for a special detector. In this case, we have more detector noise. We reduce this solution of the spectra, but we have a very good point. It's very fast. So to measure the spectra, we only need 1 millisecond. We have also normally a lower price, and the installation can be inside the plant. Now I have a look to a spectrometer system. What's important for the NIR analytics? First discussion was what we want to do, FTA NIR or diode arrow NIR spectrometer. Or in this case, I have a picture of my NIR-Photometer. So in our cases, in the next slides, I want to have a look to the diode arrow NIR or the NIR-Photometer. So we have different parts inside the system. We have a black radiator, that's normally a halogen lamp. Then we have the glass fiber. We have connectors of the glass fibers and go through the sample cell back to the optical system. So if we have a look to the lamp, the radiation of the lamp follows the Wienschen radiation law. That means it's depending from the temperature of the filament. The light of the lamp depends from the temperature of the filament. So have here a very constant radiation. We need a constant temperature and also a constant intensity. Normally, we are doing this by controlling the current through the filament, and with a number of the voltage which we are needing for this, we know something about the lifetime of the lamp. So then we have the glass fiber. A little bit complicated is the input inside the fiber, but normally this is no problem. Can you see my error here, or should I use a laser? I hope you can see it. Okay, so we have here the fiber bundle. In this case, since it is 3 fibers, one is for making a shortcut directly to the detection unit. The other one go to the sample cell 1 and to the sample cell 3. Depending from this system, we can also make more sample cells, but normally 2 sample cells are enough. So then we have the sample probe. In my opinion, it was very important that the path length is bigger than 2 millimeters, but we have to take care about the absorption maximum. It should be smaller than 1. That means minimum 10% of the light should go through the sample cell. It's an area where we have the biggest absorption. So then we have the optical switch here. In former days, we have a mechanic optical switch, but nowadays I'm sure it's better to have an electronic part in this position without any moving parts. Coming to the detector unit, the energy of the photons in the NIR area, it's very low, and so the detector noise depends from the temperature. So we have to cool the detector, but also in this kind, the filters, that's a photometer, a more channel photometer. We have to cool the detector and also the filters. In other words, if we have a spectrometer in this position, we have also to cool the detector. So very important, cooling to a constant temperature, normally minus 30 degrees Celsius. We have to take care about the bandwidth of the filters. We are using filters. If we are using array detectors, sometimes we have blind spots. So this is very important if we make a transformation of our calibration. So then we have here the signal variation evaluation. Normally, we make the dark current correction. That means here is also a possibility, force point, no light goes through the switch. And we measured the intensity, shown intensity of the detector, and build the difference about the measured intensity and the dark current intensity. And because I'm talking about the problems of the temperature of the filament of the lamp, normally we referencing the lamp directly. Then we have normally an offset correction of about at the point in the NIR spectrum that's normally nearby 1300 nanometers, where all organic components have no absorption. So then we can discuss how we can get the result. Should we use an embedded system, or is it better to transfer the spectra to an external PC? Calibration with the external PC, it's quite nice, but normally we have always the problem. We are using Windows PCs, and at least after 5 years or 7 years, we have to update it to a new system, new version of Windows, and then we started with really problems to have the old software transfer to the new PC. So in my opinion, it's really better to use embedded systems. So last not least, how we can get the results to the DCS system. Former days, we are using analog signals. Nowadays, we have the digital bus system, which is more accurate. So I have spoken a lot about what we can do for reliable analytics. Now have a look what was the technique 30 years ago. In 1990, I installed my first NIR Analyzer. This is a blue machine here. And this machine can measure NIR spectrum at 64 spectral points, but no optical multiplexing was possible. So we want to analyze, in this case, 5 sample streams. We have to switch the fluid. This is 5 valves inside the sample cell, what's installed inside this cabinet, because we can't measure the temperature, or we can't calculate the influence of the temperature. We temperated the sample inside this cabinet. And inside this blue box, we have an embedded system, which is running more than 30 years without any problems. We started with DOS 2.0 and finished with Windows 7. All over the 30 years, it was possible to communicate with this analyzer. And the embedded system still running stable. So 3 years ago, we decided to switch this to an NIR-Photometer with 5 channels. And we are using 2 sample cells. We reduced this situation to 2 photometers, so 2 cabinets with 2 photometers and only 2 sample points. And for calculations, the concentration, we don't use any more PLS and chemometrics calibration. We use Excel with a solver and have a 5.5 calibration matrix. Also, we can calculate the influence of the temperature because we measured the temperature. It's not stabilized to a constant temperature. We measured the temperature and can give inside the calibration matrix. So have a look to the results. 30 years ago, I have a look about the product before and after reactor. Now we have a liquid switch. So we measured 1 hour at this position, low concentration of our product, and after reactor, high concentration of the product. And then we go back and switch always 1 hour to between both points. So what's about the side product? One of the most important points. Take care, this is from 0 to 0.4. Maximum concentration of the side product is 1 gram per liter. So we have to take care that it's always smaller than this. You see, it's not so easy to measure it with this technology, the side product. We have a variation about 0.05 grams per liter. But for NIR, 0.05 gram per liter is really, really good. This was a system developed in the 1980s. And here I show the trend of the water before and after reactor. And you see also, same like here, switching the sample points, but the measuring is very stable. What we can say about this analytics? We can reduction the lab analysis. Normally we have 3 times per day that normally more than 6 hours per day. And later on, we only make the analyze 1 time a week. We have a simpler control of the plant, faster startup, increasing amount of product. But the maintenance of the system, we need 1 time a year, 2 days for make a good maintenance. The difficulty was the drift of the side product over 1 year. We go to a photometer. It's a KISS analyzer. It's not so complicated like a spectrometer. And we have a look to the long-term stability. Here it's a concentration of the product after reactor. This is before. This is also here over 12 hours, and you see very low noise. And here the next is the water. Here, it's coming here. That's a side product. You know, before it was a lot of noise on it. And here is now really stable. And this is the water. It looks more noisy, but take care. It's from 2.80 to 2.28. So with a photometer, it's really possible to measure better than 0.05 grams per liter. So in the last 10 minutes, I've spoken a lot about what we have to do that we can get a reliably measuring point. Now let's have a look. What's the cost about the technology? So the analytic systems, it's not too easy to find out the real price, but normally if we have a 2-component analysis like density, sound velocity, spectrum-specific NIR gas analytics, we are speaking about 30,000 to 60,000 euros over the project costs. And later on, we have a maintenance cost about 2%. And if we calculate it for a return of investment in between 33% per year, we have to get money around about $15,000 to $20,000 euros. If we have a 3-component systems, we are speaking about 70,000 to 100,000 euros. Total investment is a little bit higher, 2 to 3%. And we have to earn every year around about 50,000 euros. We make a multi-component analysis by spectrometric measurements or chemometrics. We are speaking about 100 to 200,000 euros. Possible, the total investment as a maintenance can be between 3 and 6%, depends from the quality of the calibration. And here we have to earn more than 100,000 euros per year. If we use gas chromatography or the online HPL, liquid chromatography, we are speaking about 300,000 euros. And here we have really high maintenance, about a lot of small parts are inside the chromograph, SGC or HPLC. And so we have high maintenance, and we need also, we have to earn a lot of money. But also this analytic methods are possible to bring it inside the process. So let's have a look to the, I forgot something. For checking cost calibration, it's quite easy to have a look to the cost of the analyzer and multiply it with P. Then you have really the total project cost. Here's an example for a project with the NIR application. We started with the basic engineering. Then we have the around about 30,000 euros. Then we have the investment costs for the spectrometer and the sample cells and the glass fibers, possibly the cabinet. Then something happened during our project, so we need repair costs for the project. and also commissioning costs by installation, connections, wiring, and transfer the signal to the DCS system. Last not least, we make the startup, and then we have to pay for the calibration around about 50,000 euros. In sum, this is a 250,000 euros. And now we should have a look, is it successful? We have to look to return the measurement, what we can earn by this measurement, avoidance of overfeed, around about 50,000, increasing plant yield, saving energy. Then we have fixed, can reduce the work for personnel, and at least we get 100,000 euros per year. But we have also to make a maintenance about 25,000 euros. We give in, and then we get as a result, that is payback period of at least 2 years. That depends about, we need also for money for the credit of the money. And we have a return of investment of 60%. It's really bigger than 23%. But it's not so easy to get real numbers. So it's easier to pinpoint the profit derived from process improvement when we have a look through the generating indices. So normally our production have a value about 70 to 130% per year. For our calculation, that's 100%. The typical investment of a chemical plant is between 30 and 80 million euros. Our calculation 15 million euros. So that means that we produce around about 50 million euros chemical product with our plant. So we need an annual profit in the first 5 years of 35%, later on of 10%. For our calculation, I take 10%, and then I have a look to a lot of projects. What was a typical value that we are doing? We increase the plant capacity and make a profit about 50 to 150,000 euros and have investment for 120 to 250,000 euros. Maintenance costs 5 to 15%. So we have a profit per year around about 30%. If we increase the plant yield, the amount is not so big, but the money we get is really higher. So we come to values bigger than 40%. Energy saving in the last years, it was not so important, but nowadays it's really important because of the price of the energy. In former days, we have only 25% up to 70%. I think nowadays we are on about 100%. So we can get old projects which are laying in the desk. So if we have saving personnel, it's possible around about 10% of the shift personnel we can reduce, but we don't want to kick them out. Normally, this is only important if we put plants together and we don't need so much, or we build a second plant to a sister plant nearby this old plant. Then it's important that we don't need so much shift personnel. So what is the result? 45% of all cases, the ROI is delivered in less than 2.5 years. But take care, about 10% of our projects required more time than we expected. And the increasing of the plant yield is a better possibility than the increasing of plant capacity. Personnel interest only if a key requirement change as a result of plant expansion. One of the last point is, if we have a real reliable complex analytics, we want to reduce our maintenance. We developed the system in Europe or in Germany and installed it worldwide. And for have a good maintenance, we don't want to travel. We want to see it from our desk. Here's a plant site, different analyzers, local operation, and then we go over the internet directly to our analyzers and can have a look what's the situation of the analyzers. Former days, we also use modems. This was a development from the 19th. And it's very important to have a logbook about the condition of the analyzer, information from the sampling point, information from the sampling loop, and important process parameters. Then we can say from our desk, oh, the problem, what you are saying to where you are calling us can be from this point, and the local maintenance team can then fix the bug. But very important, how we get the maintenance team. The maintenance team should be, we need lab personnel and also measure and control engineers. This is quite not so easy to get a lab personnel inside the plant or a measure and control engineer inside the lab. Okay. But this team is a part during installation. He learned about the analyzer during the startup and also is written a part of the manuals. And the personal contact during this time is very important. See here, like the fishermen in the area of Vietnam. Now you need a lot of fishermen, but at least they have here the good result. We are only strong as a team. Coming to the end, production requires reliably PAT in place. This is achieved by applying all available process experience by planning. Also planning is very important. The analyzer should be simple and robust. KISS principle. We want to have a substance-specific measurement using measurement information from the sample volume. Inline, it's better than online. Remote monitoring and maintenance condition monitoring are very important to reduce our traveling costs. And the after-sales service provided by trained specialists is very important. What's about the return of the investment? Generated by expensive systems, increasing in plant capacity, improve yield, more effective part load operation. Plant expansion requires no additional personnel. And in the feedback about a lot of projects is showing that 55% of all cases, the ROI is delivered in less than 2 years. Okay, thanks for your attention. If you have questions, please take it.
So thank you very much, Mr. Hajduk, for this interesting presentation. So during the presentation, there were numerous questions from our audience. Unfortunately, we do not have a lot of time, so we have almost time for only one question. And this would be, so you said that 75% of all cases of ROI is achieved in less than 2.5 years. So what is the average ROI of PAT projects?
The average is smaller than 2 years.
Okay. So in all PAT projects that you have, the average will be...
We have to look before. Mm-hmm. If we say, oh, we need 5 years, normally we don't do it.
Okay. Thank you very much, Mr. Hajduk. So before we finish, I would really appreciate your feedback. So please let me know, did you get new insights in the second webinar of the year? Our next PAT Forum webinar is already in preparation. We will keep you updated via LinkedIn, and you always find the latest information on our PAT Forum website. As a participant, you will receive the PAT Forum newsletter of the next webinar automatically. So I would be happy if you would join us again and tell your colleagues about it. Thanks you for your participation and have a nice day and goodbye.